configuration in MyBatis.
Now we are focusing on configuration. The MyBatis configuration contains settings and properties that have a dramatic effect on how MyBatis behaves. The high-level structure of the document is as follows: configuration, properties, settings, type aliases, type handlers, object factory, plugins, environment, transaction manager, data source, database ID provider, and mappers. Here you can see MyBatis configuration co-construction process. Configuration creation. When analyzing my SQL session factory before building, method was not interpreted in detail and told the pentagonist of source distribution configuration was initialized in this method. Here the XML config builder. The XML configuration file mainly used to analyze MyBatis and store the analysis results in the configuration object, and create a SQL session factory after getting the configuration object. The entry XPath parser. XPath parser is an XML analyzer. If the specific analysis is constructed, it will not be described. Entry environment. In order to ensure multi-environmental configuration, this parameter specific environments medium configuration. Entry properties. Properties are the key value storage structure that inherits the hash table form, and configuration initialization through the above analysis. The configuration initial operation was in xconfig builder. Type alias registry. What is type alias? Database like MySQL or Oracle support alias, and MyBatis also provide this mechanism. The type alias in MyBatis is set to alias for the types commonly used in MyBatis, using aliases instead of specific type. What is the type purpose of type alias? The type alias is mainly used to replace complex type of multi-limited names in MyBatis, and is used to set parameter type and return result type in the mapper configuration file. Language driver registry. Language driver registry is the SQL parser in MyBatis, which stores different SQL parsers and is the hashmap storage method along with type alias registry. Analysis MyBatis-config.xml. Parser.parse The above will will the initialization of XML config builder and initialization of configuration. Pass configuration xnode. This method is used to analyze mybatis-config.xml to analyze various labels and store them in the configuration object. Here configuration is connected to XML builder, XML config builder configuration, configuration, XML config builder.pass, xnode colon pass dot evaluate eval node method, pass configuration and configuration. Here configuration is connected via type alias registry, and here the configuration is connected to SQL via language driver registry. Here XML config builder.pass method is connected to mybatis-config.xml. Here the xnode colon pass dot eval node method is connected to mybatis-config.xml. Here pass configuration is connected to mybatis-config.xml configuration. Here you can see configuration sources. There are three sources of configuration. mybatis-config.xml start the file, the overall configuration and the overall components are all derived from this. Mapper.xml SQL mapped statement for /result mapper all comes from this. At annotation, SQL mapping and results episoding another expression. Here you can see a configuration configuration sources. mybatis-config.xml is connected to configuration. Mapper.xml is connected to configuration, and at annotation is connected to configuration. Here you can see a mapper registry, caches and type handler registry, result maps, and type alias registry, interception chain. Here new executor, new parameter handler, new result set handler, and new statement handler. These are connected to here interception chain. Here you can see overall relationship in configuration element. Configuration information comes from XMLs and nodes. Each file and node is composed of several configuration element presents a nested relationship. The overall relationship is shown in this figure. Here properties, type handler settings and environments, type aliases and mappers. Properties, settings, type aliases, and type handlers, environment, and mappers are in configuration here. Here the cache ref, SQL, parameter map, result map, select, delete, insert, and update are in mapper. At options, select, at insert, at delete, at update, at cache namespace, at cache namespace ref, at select key, at param, at result, and at result map in annotation. If, for each, trim, choose, where, set, and include are in script. Here you can see element bearer. Whether It is XML or annotate that the weakest element of this configuration must be converted to the Java configuration attributes or objects components to carry. Corresponding relationships as follows: the global configuration config.xml carried by the configuration object attributes to here SQL mapping select, insert, or at select, etc. carried by mapped statement objects. 3 cache or at cache namespace carried by cache object. For the result is a mapping carried by the object of result map. Here you can see MyBatis -config.xml is connected to mapper.xml and annotation. Here mapper.xml interact with at annotation, and mapper.xml is connected to select and update, and these are connected to select, update, etc. are connected to script here, and mapper.xml is connected to cache-ref. Mapper.xml is connected to result map. Here the at annotation is connected to at select, at update. Here at annotation is connected to at select, at cache namespace, and at namespace ref. Here MyBatis -config.xml is under here configuration, with configuration, and select, update, and script at select, at update are related to mapped statements. Here cache-ref, at cache namespace, at cache namespace ref are related to cache. Here result map is related to result map here. Here here you can see a configuration file analysis. Configuration file analysis requires us to discuss separately. First, to analyze the XML analysis process. The XML configuration analysis its bottom layer and uses DOM4J to dissolve into a node tree first, and then matches different analyzers according to the different node types. Eventually it is dissolved into a specific component. Base of the analyzer is the base builder, which contains overall configuration object. The purpose of this is that all components to be analyzed must be concentrated to a configuration at the end. Next, understand the role of each analyzer. XML config builder analyze the config.xml file and directly create a configuration object for analyzing overall configuration. XML mapper builder analyze mapper.xml files content including etc. Mapper builder assistant mapper.xml parsing aid. In a mapper.xml, cache is shared with the statement, SQL statement, and the allocation of shared components is achieved by this parsing. XML statement builder SQL mapping analysis is select, update, insert, delete element dissolution into a mapper statement. SQL source builder SQL data source analysis, which interpolates the declared SQL to perform SQL. XML script builder SQL node script set in the analysis dynamic SQL data source. This is the class base builder, and these are the direct known subclasses. XML config builder, XML script builder, SQL source builder, XML statement builder, XML mapper builder, and mapper builder assistant. Here you can see XML file analysis process. The overall analysis process starts with XML config builder, and then gradually analyzes inward until all nodes are analyzed. We can understand the overall analysis process during the period through a mapped statement analysis process. The process description here, one XML config builder receives a config .xml input stream and then create an empty configuration object. XML to XML config builder analyze overall configuration, and 3 XML config builder mapper elements for analysis. Designed kappa.xml files, mapper.xml files by resource URL, and XML mapper builder then analyze cache and result set configuration and other public configurations. XML mapper builder analyze SQL mapping, select, insert, update, delete. XML script builder analyze, generate SQL data sources including dynamic scripts. XML mapper builder build statement, mapper builder assistant, set cache and add to configuration. Here you can see XML config builder and its pass, and then mapper element is connected to cache ref and result map in SQL, result map SQL in XML mapper builder. And here then statement, select, update, delete, insert, and it's connected to again move to a class, and here statement is connected to XML statement builder, and here SQL source is connected to XML script builder, and here statement is connected to statement in mapper builder assistant, and here it's configuration in mapper builder assistant. Now we are considering annotation configuration analysis. The realization of the bottom of the annotation analysis is achieved by there are two ways. One is to directly specify the interface name, and the other is to specify package name and then automatically scan all the interfaces class under package. These logics are implemented by mapper registry. It received an interface class parameter and create a dynamic proxy factory. For the interface based on the parameter, then passes the internal method annotation to generate each mapper statement, and finally adds it to configuration to complete the analysis. Here you can see XML config builder in its past and is a mapper element in package or package class. Here the mapper element is connected to add mappers in mapper registry. Here add mappers is connected to add mapper, and add mapper is connected to pass cache ref in mapper annotation builder here. Then it's the pass statement, then pass statement is connected to mapper statement and configuration in mapper build assistant, and then statement. Now we are considering responsibilities of SQL session factory builder. SQL session factory builder is responsible for creating session factory SQL session factory instances. SQL session factory builder can construct an instance of SQL session factory from XML configuration file or an instance of pre-customized configuration. The configuration class contain all the content you may concern about with an instance of SQL session factory. SQL session factory builder applies the builder design pattern. It has 5 builds method that allow you to create session factory instances from different resources. Here the SQL with regarding SQL session lifecycle of the SQL session factory builder, the SQL session factory builder can be instantiated, used, and discarded. Once the SQL session factory is created, it is no longer needed. Therefore, the best scope of an instance of SQL session factory builder is the method scope, that is local method variables. You can reuse SQL session factory builder to create multiple session factory instances, but it is better not to keep it forever to ensure that all XML parsing resources can be released for more important things. Here the SQL session factory builder is connected to mybatis-config.xml, which is connected to configuration and which is connected to SQL session factory. Now we are here. You can see SQL session factory responsibilities. SQL session factory is responsible for creating SQL session instances. SQL session factory applies the factory design pattern, which provides a set of methods for creating SQL session instances. Method description: the default open session method has no parameters. It will create a SQL session with the following characteristics. Transaction is transaction scope will be returned. Transaction scope will be turned on. That is not automatically committed. Connection objects will be obtained from data source instance configured by current environment. Transaction isolation level will use the default settings of the driver or data source. Prepared statement will not be reused, and the updates will not be processed in batches. Transaction isolation level represent the transaction isolation level, which corresponds to 5 transaction isolations levels. The executor type and enumeration type defined 3 values. Executor type dot simple. This type of executor has no special behavior. It creates a new prepared statement for execution of each statement. Executor type dot reuse. This type of execution will reuse the prepared statement. Executor type batch. This type of executor will execute all update statement in batches. If select is executed in the middle of the multiple update statement will be separated if necessary to facilitate understanding. The SQL Session Factory life cycle. SQL Session Factory should always exist in the form of a singleton during the runtime of the application. Here SQL Session Factory is connected to Open Session. Open Session is connected to SQL Session. Here none read committed, read run none read uncommitted, read committed, repeatable read, and serializable is connected to transaction isolation level method. Here simple reuse and batch a simple reuse and batch are connected to executor type. Here auto commit, transaction isolation level, executor type, and connection is connected to Open Session. Here you can see the methods of SQL Session class. Method of the SQL Session class can be roughly classified according to the following figure here. The SQL Session responsibilities. The main Java interface of MyBatis is SQL Session. It contains all the methods for executing statements, obtaining mappers, and managing transactions, SQL Session lifecycle. SQL Sessions is created by an instance of SQL Session Factory, and SQL Session Factory is created by SQL Session Factory Builder. Note, when MyBatis is used with some dependency injection frameworks such as Spring or Goose, SQL Sessions will be created by the dependency injection framework, so you don't need to use SQL Session Factory Builder or SQL Session Factory. Each thread should have its own SQL Session instance. The instance of SQL Session is not thread safe, so it cannot be shared. So its best scope is the request or method scope. You must not put the references of SQL Session instance in the static field of a class. Even the instance variables of a class. Never place a reference of a SQL Session instance in any type of managed scope such as HTTP session in the servlet framework. The correct use of SQL Session in the web is every time you receive an HTTP request, you can open a SQL Session, return a response, and close it. Here you can see a SQL Session, and here you can see identity list map, and here select insert update. Here select XSX here, and here statement and parameters are here. Then here commit rollback, and here flush statement, clear cache, close, get configuration, get mapper, and get connection. Now we are considering the internal working mechanism of SQL Session. We have already understood the MyBatis encapsulate the access to the database and put session and transaction control of the database into SQL Session object. So how does it work? Next we analyze the source. So here SQL Session internal processing mechanisms for insert, update, delete, and select are basically the same. So next I will take complete select query process. As an example, we can consider select query process. SQL Session subcomponents. SQL Session is the top level interface of MyBatis, which provide the methods of executing statement, obtaining mappers, and managing transaction. In fact, SQL Session realizes the assurance of task by aggregating multiple subcomponents and letting each subcomponent to be be responsible for its own function. So let's us briefly understand core subcomponents of SQL sessions. Executor is the executor which is responsible for generating dynamic SQL and managing cache. Executor is the executor interface. There are base executor, simple executor, batch executor, reuse executor, caching executor. Statement handler. The statement handler object is responsible for setting the query parameters in the statement object, processing the result, processing the result set returned by JDBC. And processing the result sets into a list collection and return. Family members of statement handler. Statement handler is the interface. Base statement handler is an abstract class that implement statement handler with some common methods built in. Simple statement handler is responsible for processing statement. Prepared statement handler is responsible for processing prepared statement. Callable state handler is responsible for processing callable statement. Routing statement handler is responsible for processing the specific subclass and of statement handler and choose to instantiate simple statement handler, prepared statement handler, and callable statement handler according to the statement type. Parameter handler. Parameter handler is responsible for converting incoming Java objects into JDBC type objects and filling values for the dynamic SQL of prepared statement. Parameter handler has only one concrete implementation class, namely default parameter handler. Result set handler. Result set handler is responsible for two things: process the result set generated after the statement is executed, and generate the result set. Processing the output parameters after the execution of the stored procedure. Result set handler has only one concrete implementation class, namely the default result set handler. Type handler. Type handler is responsible for converting between Java objects types and the JDBC types. SQL session and mapper. Here and here you can see SQL session interacts with executor. Executor interacts with statement handler. Statement handler interacts with the parameter handler, and parameter handler is connected to type handler and restatement. Here statements are connected to result set, and result set is connected to type handler, and result set handler. Type handler is connected to the result set handler here. And here the result set SQL session is connected to executor. Executor is connected to statement handler. Statement handler is connected to parameter handler, and here statement, and parameter handler is connected to statement, and type handler is connected to statement. Prepare statement, simple statement, and callable statements are inside statement. Statement is connected to result set is connected to type handler, and type handler is connected to result set handler. Here result set is connected to result set handler. Result set handler is connected to statement handler is connected to execute is connected to SQL session. And here you can see SQL source and result maps are inside the mapped statement mapper. Map statement mapper is inside configuration MyBatis, and here you see params object, row bounds, and bound SQL. And here this SQL session executor, statement handler, parameter handler, type handler, result set, and configuration MyBatis param object, row bounds, bound SQL are inside MyBatis, and here statement and result set inside JDBC, and JDBC interacts with the database. Here here MySQL, Oracle, H2, PostgreSQL, DB2, etc. Here you can see a SQL session. As its name suggests, SQL session corresponds to a database session. Since database session is not permanent, the life cycle of a session should not be permanent. On contrary, you need to create it every time you access the database. Of course, it does not mean that you can execute. You can only execute SQL once in SQL session. You can execute multiple times when the SQL session is to be recreated once it is closed. Let's look at how to get SQL session first. For SQL session, factory builder reads the configuration file of MyBatis and then builds a default SQL session factory. When we get the SQL session factory, we can get SQL session object through the SQL session factory. Through the above steps, we have obtained a SQL session object. Then you can and here you can see actor is here, and SQL session factory builder, default SQL session factory, and default SQL session. Is one built actor is connected to SQL session factory builder via build. Here SQL session factory is connected to itself, then via build configuration, and SQL session factory builder is connected to default session SQL session factory, and then return default SQL session factory to SQL session factory builder. Then it's connected to here. The SQL session factory builder is connected to return default SQL session factory to the actor. Then it's actor here. The open actor is connected to default SQL session factory via open session. Then default session factory is connected to itself via open session from data source. Then default session factory is is connected to default SQL session factory is connected to default SQL session here. Then it return default SQL session. Then it return default SQL session factory to actor. Here you can see a SQL session creation process. SQL session is connected to SQL session factory via open session. SQL session factory is connected to transaction factory via new transaction. Transaction factory is connected to transaction via new. Here transaction is connected to default source connection and transaction isolation level. You can see here executor. Execute transaction default source connection and transaction isolation level is in one group, and with this group and data default execution is another group, and this is connected to SQL session. Here you can see SQL session implementation process. Here via select list connected to SQL session. To SQL session is connected to configuration via get map statement. Configuration is connected to map statement via ID. Map statement is connected to SQL session. SQL session is connected to executor via query. Execute is connected to statement handler via new statement handler and prepare. Statement handler is connected to connection via prepare statement. Statement handler statement handler interacts with connection. Statement handler execute is connected to statement handler via parameterize, and statement at 9 statement handler is connected to parameter handler via set parameters. 10 executor is connected to statement handler via query. Here statement handler is connected to statement via execute. Statement is connected to statement in IMPL via execute. Here 12. Here in the 8-step connection is connected to connection in IMPL via prepare statement here. Here connection interacts with connection IMPL. Here statement interacts with statement IMPL, and here statement handler interacts with statement, and statement handler is connected to result set handler. Inside result set handler you can see handle result set, handle cursor result set, handle output parameters. Result set handler interacts with type handler, set parameter, get result. Result set handler is connected to type handler via get results. Here parameter handler is connected to type handler via set parameter, and parameter handler is connected to statement. Connection IMPL interacts with DB. Here statement IMPL implementation interacts with DB. Here SQL session configuration, connection, executor, map statement, and statements are in map statement level. Here statement handler, result set handler, parameter handler, type handler are in statement level, and here connection IMPL and statement IMPL in JDBC level, and here DB is in DB level. Here basically connection, executor, map statement, and statement are in map statement level here basically. Here you can see the executor. The relationship between executor and SQL session is like mayor and secretary. SQL session is just a facade, and real thing is executor. SQL sessions operations on database are all done through executor. Like SQL session, executor is created dynamically. It can be seen that If the cache is not enabled, the created executor is only one of three basic types. Batch executor is especially used to execute batch SQL operations. Reuse executor will reuse statement to execute SQL operations. Simple executor simply executes SQL without anything special. When the cache is enabled, it is enabled by default, and there is no reason to disable it. The caching executor is created that takes the previously created executor as it's only one parameter. Caching executor searches the cache before querying the database. If it is not found, it calls the delegate, that is executor object passed in during construction to query the database and store the query result in the cache. Executor objects can be interpreted by plugins. If the plugin for the executor type is defined, the resulting executor object is a proxy object inserted by the plugin. Next, we look at the execution process of SQL. Above we got the mapper proxy. Each mapper proxy corresponding to DAO interfaces. So how do we use mapper proxy when we use it? The mapper proxy, we know that access to the method of proxies object will be implemented in the invoke of the proxy. The mapper method, like a distributor, we choose to like distributor, he chooses different SQL session methods to execute according to the parameters and return value types. In this way the mapper object and SQL sessions are truly associated. Now that we are back to SQL session, as we mentioned earlier, SQL session is just a facade, and it is the executor that really plays the role. We access the SQL session method will eventually fall to the corresponding method of the executor. Executor is divided into two categories. One is cache executor and the other is ordinary execution. The creation of the executor has been introduced before, so let's look at the crude method of a SQL session. Cache executor has the important attribute delegate, which stores a certain type of common executor. The value is passed in when framing, when executing the database update operation, which directly call the update method for the delegate, and executing query method if it first tries to get the value from the cache. Ordinary executor, there are three types. They all are inherited from the base executor. Batch executor is specially used to execute batch SQL operations. Reuse executor will use statement to execute SQL operations, and simple executor simply execute SQL without anything special. Then through layer by layer calls, we will finally come to the do query method. Here let's find an executor to see implementation of do query method. I choose here a simple executor here. there are 3 built-in execute types in MyBatis. The default is simple. In this mode, it creates a new prepared statement for execution of each statement and submit a single SQL statement, while the batch mode reuses the prepared statement and executes all the batches. Update statement, obviously the batch performance will be better, but the batch mode also has its own problems. For example, and in the insert operation before the transaction is committed, there is no way to obtain self-incrementing ID, which does not meet the business requirement in certain types of situations. Here you can see actor, mapped proxy, mapped method, default SQL session, simple executor, prepared statement, and result set here. See here actor is connected to mapped proxy via invoke. Mapped proxy is connected to mapped method via execute method. Here map method is connected to itself via CRUD. Here map method is connected to default SQL session. Default SQL session is connected to simple executor via query method. Here simple executor is connected to itself via query from the database, and simple executor is connected to itself via do query. And here simple executor is connected to prepared statement via query. Prepared statement is connected to itself via execute, and here prepared statement is connected to handle result set. Prepared statement is connected to result set handle via handle result set method, and it returns to prepared statement. The result set handler then return to the prepared statement. It's returned to the simple execute. It's returned to the default session, and it returned to the actor. As an example, we can consider package class class configuration. This is in the package org.apache.ibatis.session. Here we are considering building SQL session factory from XML. MyBatis includes a utility class called resources that contains a number of methods that make it simpler to load resources from the class path and other locations. This is the interface SQL session factory creates an SQL session out of a connection or a data source. This is in the package org.apache.ibatis.session. Every MyBatis application centers around an instance of a SQL session factory. A SQL session factory instance can be acquired by using SQL session factory builder. SQL session factory builder can build a SQL session factory instance from an XML configuration file, or from a custom prepared instance of a configuration class. Building a SQL session factory instance from an XML file is very simple. It is recommended that you can use class path resource for use a class path resource for this configuration, but you could use any input stream instance, including one created from a literal file path or a file / URL. MyBatis includes a utility class called resources that contains a number of methods that make it simpler to load resources from a class path and other locations. Here is a simple example. The configuration XML file contains settings for the core of the MyBatis system, including a data source for acquiring database connection instances, as well as a transaction manager for determining how transaction could be scoped and controlled. The full details of XML configuration file can be found in the documentation, but here is a simple example. While there is a lot more to XML configuration file, this example points out the most critical parts. Notice the XML header required to validate XML document. The body of the environment element contains the environment configuration for transaction management and connection pooling. The mappers element contains a list of mappers, the XML files, and or annotated Java interface classes that contain SQL code and mapping definitions. Now we are considering building a SQL session factory without XML. If you prefer to directly build the configuration from the Java rather than XML, or create your own configuration builder, MyBatis provide a complete configuration class that provide all the same configuration options as the XML file. Here SQL session factory creates an SQL session out of a connection or a data source. Notice in this case the configuration is adding a mapper class. Mapper classes are Java classes that contain SQL mapping annotations that avoid the need for XML mapping. However, due to some limitations of Java annotations, the complexity of some MyBatis mappings, XML mapping is still required for most advanced mapping, for example, nested join mapping. For this reason, MyBatis will automatically look for and load a peer XML file if exists. In this case, blog mapper.xml would be loaded based on the class path and the name of the of blogmapper.class. Now we are considering acquiring a SQL session from a SQL session factory. For example, here the interface SQL session, the primary Java interface for working with MyBatis. Through this interface, you can execute command, get mappers, and manage transactions. This is in the package org.apache.mybatis.session. Now you have a SQL session factory here. The name, as the name suggests, you can acquire an instance of SQL session. The SQL session contains absolutely every method needed to execute SQL commands against the database. You can execute mapped SQL statements directly against SQL session instance. For example, here, while this approach works and is familiar to users of the previous versions of MyBatis, here is now a cleaner approach. Using an interface, for example, blockmapper.class that properly describe the parameter and return value for a given statement, you can now execute cleaner and more type-safe code without error-prone string literals and casting. For example, here, now we are considering properties in configuration XML. For example, here, these are externalizable, substitutable properties that can be configured in a typical Java properties file instance or passed through sub-element of properties element. For example, here, the properties can then be used throughout the configuration files to substitute values that need to be dynamically configured. For example, here, the username and password in this example will be replaced by the values set in the properties element. The driver and URL properties would be replaced with various content from the config.properties file. This provides a lot of options for configuration. Properties can also pass into SQL session builder .build methods. For example, here, if a property exists in more than one of these places, MyBatis loads them in the following order. Properties specified in the body of the properties element are read first. Properties loaded from the class path resource, so URL attributes of the properties element are read second and override any duplicate properties already specified. uh, properties passed as a method parameter are at last and override any duplicate properties that may have been loaded from properties body and the resource URL attributes. Thus, the highest priority properties are those passed in as a method parameter, followed by resource URL attributes, and finally the properties specified in the body of the properties element. Or since MyBatis 3.4.2, you can specify default value placeholder as follows. This switch is disabled by default. If you specify default value placeholder, you should be able to you should able to use this feature. Here, if the username property is not present, username become ut user. Now we are considering settings. An example of settings element fully configured is as follows. Here the settings name cache enabled globally enables or disabled any cache configured in any mapper under this configuration. Valid values are true and false and default true. Here the lazy loading enabled globally enables and disable lazy loading. When enabled, all relations will be lazy loaded, and this value can be superseded for a specific relation by using fetch type attribute in it. Valid values are true or false. Default is false. Aggressive lazy loading, when enabled, any method can will load, any method call will load all lazy parameters of the object, otherwise each property is loaded on demand. Valid values are true or false, and false default values is true, and default value is false and true in 3.4.1. Multiple result sets enabled, allow or disallow multiple result sets to be returned from a single statement. Compatible driver required. The values are true, valid values are true or false, and default is true. Use column label, uses a column label instead of the column name. Different drivers behave differently in this respect. Refer to the driver documentation or test out both to determine how your driver behaves. The valid values are true or false and default to true. Use generated keys, allow JDBC support for generated keys. A compatible driver is required. This setting forces generated keys to be used if set to true, as some drivers deny compatibility but still work. For example, Derby, where valid values are true or false and default is false. Auto mapping behavior. Specify if and how MyBatis should automatically map columns or fields columns to fields or properties. None disables auto mapping, and partial will only auto map results with no nested result mapping defined inside. Full will auto map results mapping to any complexity containing nested or otherwise. Valid values are none, partial and full. Default is partial. Auto mapping unknown column behavior. Specify the behavior when detects an unknown column or unknown property type of automatic mapping target. None do nothing. Warning output warning log. The log level of org.apache.ibatis.session.auto mapping unknown column behavior must set to warn, and failing fall mapping throw SQL session exception. None valid values are none, warning, and failing. Default is none. Default executor type. Configure the default executor. Simple executor does nothing special. Executor reuses prepared statement. Batch executor reuses statement. Batch updates. Simple default values for simple reuse batch. Default to simple. Default statement timeout sets the number of seconds the driver will wait for a response from database. Valid values are any positive integer. Default is not set. Default fetch size sets the driver a hint as to control fetching size for the return results. This parameter value can be override by the query string. Valid values are any positive integer, and default to set not set is null. Safe row bounds enabled. Allow using round bounds on nested elements. If allow, set the false. Default valid values are true or false, and default to false. Safe result handler enabled. Allow using result handler on nested statement. If allow, set the false. Default default value is true. Map underscore to camel case. Enable automatic mapping from classic database columns names underscore column to camel case classic Java property names a column. Default valid values are true or false. Default to false. Local cache scope. MyBatis uses local cache to prevent circular references and speed up repeated nested queries. By default session, all queries executed during a session are cached. If a local cache scope equals statement, local session will be used just for statement execution. No data will be shared between two different calls to the same SQL session. Valid values are session or statement. Default to session. JDBC type for null. Specifies JDBC type for null values when no specific JDBC type was provided for the parameter. Some drivers require specifying the column JDBC type, but others work with generic values like null, varchar, and other. JDBC type valid values are JDBC type enumeration, most common null, varchar and other, default to other. Lazy load trigger methods specified which object methods trigger lazy load. Valid values are a method name list separated by commas. Default is equal, clone, hash code and two string. Default scripting language specify the language used by default dynamic SQL generation. A type alias or fully qualified class names are valued values. Default to org.apache.ibatis.scripting.xml tags.xml language driver. Default enum type handler specify the type handler used by the default for enum since 3.4.5. Valid values are type alias or fully qualified class name. Default to org.apache.ibatis.type.enum type handler. Call setters on nulls specify if setters so maps put method will be called when a retrieved value is null. It is useful when you rely on map.keyset method or null value initialization. Note primitives such as int, boolean, etc. will not be set to null. Valid values will be true or false. Default to false. Return instance for empty row. MyBatis by default return null when all columns of a return now are null when this settings is enabled. MyBatis return an empty instance instead. Note that this is also applied to nested results, that is collection and association, since 3.4.2. True or false and default to false. Log prefix specified the prefix string that MyBatis will add to the logger names. Valid values are any string and default to not set. Log impl and specify which when logging implementation MyBatis should use. If this setting is not present, logging implementation will be auto discovered. Valid values are SL F4J or log4j deprecated since 3.5.9, log4j2 or jdk underscore logging or commands underscore logging or std out underscore logging or no logging. Default is not set. Proxy factory specified the proxy tool that MyBatis will use for creating lazy loading capable objects. Valid values are cglib deprecated since 3.5.10 and Java Assist and default to Java Assist MyBatis 3.3 or above. VFS impl specified VSF implementation. Fully qualified valid values is fully qualified class names of the custom VSF implementation separated by commas. Default to not set. Use actual param name. Allow referencing element statement parameters by their actual names declared in the method signature. To use this feature, your project must be compared with Java 8 with dash parameter option since 3.4.1. Valid values are true or false and default to true. Configuration factory, they specified the class that provide an instance of configuration. The return configuration instance is used to load lazy properties of decentralized object. This class must have a method with the signature static configuration get configurer method since 3.2.3. Type valid values are a type, alias, or fully qualified class name. Default is not set. And there are other settings like shrink white space in SQL, default SQL provider type, nullable on for each, arg name based constructor automapping. Now we are considering type aliases. For example, here the annotation interface alias, the annotation that specify alias name. This is in the package org.apache.ibatis.type. A type alias is simply a shorter name for the Java type. It's only relevant to the XML configuration and simply exists to reduce the redundant typing of fully qualified class names. For example, here with this configuration, blog can now be used anywhere that domain.blog.blog could be. You can also specify a package where MyBatis will search for beans. For example, here each bean found in domain.blog, if no annotation is found, will be registered as an alias using uncapitalized non-qualified class name of the bean. That is domain.blog.author will be registered as author in simple letters. If the alias annotation is found, its value will be used as an alias, for example below. Now we are considering type handlers. For example, here the package the class base type handler T, the base type handler for references a generic type. This is in the package org.apache.ibatis.type. Whenever MyBatis sets a parameter on a prepared statement, or retrieve a value from a result set, a type handler is used to retrieve a value in a means appropriate to Java type. For example, default there are default type handlers, for example boolean type handler for java.lang.boolean or boolean, and JDBC type any compatible boolean, for example. You can override the type handlers or create your own to deal with unsupported or non-standard types. To do the implement the interface apache.ibatis.org.apache.ibatis.type handler, or extend the convenience class org.apache.ibatis.type.base type handler, and optionally map it to the JDBC type, for example here. Using such a type handler would override the existing type handler for Java string properties and varchar parameter and results. Note that MyBatis does not support introspect upon database metadata to determine the type, so you must specify that it's a varchar field in the parameter and the result mapping to hook in the correct type handler. This is due to the fact that MyBatis is unaware of the type until statement is executed. MyBatis will know the Java type that you want to handle with this type handler by introspecting its generic type, but you can override this behavior by two means: adding Java type attribute to the type handler element, for example Java type equal string, or adding at map types annotation to your type handler class, specifying the list of Java types to associate with. This annotation will be ignored in Java type attribute has also been specified. The associated JDBC type can be specified by two means: adding JDBC type attributes to the type handler element, for example JDBC type equal varchar, or adding mapped JDBC types annotation to your handler class, specifying the list of JDBC types to associate with. This annotation will be ignored if the JDBC type attribute is also been specified. When deciding which type handler to use in a result map, Java type is known from the result type, but the JDBC type is unknown. MyBatis therefore uses combination of Java type equal the Java type, Java type equal JDBC type equal null to choose the type handler. This means that using at mapped JDBC types annotation restricts the scope of a type handler and make it unavailable for use in result maps unless explicitly set. To make the type handler available for use in the result map, set include null JDBC type equal true on at mapped JDBC types annotation. Since MyBatis 3.4.0, however, a single type handler is registered to handle Java type, it will be used by default in result maps using this Java type. For example, even without include null JDBC equal true, include null JDBC type equal true. MyBatis -config.xml. Now we are considering handling enums. That's just as easy an odd enum. Add enum ordinal type handler to the type handlers in your config file, and now each rounding mode will be mapped to an integer using its ordinal value. Enum ordinal type handler e extend enum e. This in the package org.apache.ibatis.type. If you want to map an enum, you will need to use either enum type handler or enum ordinal type handler. For example, let's say that we need to store the rounding mode that shows that should be used with some number if it needs to be rounded. By default, the MyBatis uses enum type handler to convert enum values to their names. Note, enum type handler is special in sense that unlike other type handlers that does not handle just one specific class, but any class that extend enum. However, we may not want to store names. Our DBA may insist an integer code instead. That just as easy as add enum ordinal type handler to the type handlers in your config file, and now each rounding mode will be mapped to an integer using ordinal value. But what if you want to map the same enum to string in one place and to integer in another? The automapper will automatically use ordinal type handler, and so if we want to go back to using plain old ordinary enum type handler, we have to tell it by explicitly setting the type handler to use for those SQL statement. Mapper files aren't converted until the next here we are skipping mapper files, and this is a segment of the code. Note this forces to use result map instead of result type in our select statement. That code is omitted here. The MyBatis config.xml. Each time, now we are considering object factory. For example, here the class default object factory, which is in org.apache.ibatis.reflection.factory. Each time MyBatis creates a new instance of a result object, it uses object factory instance to do so. The default object factory does little more than instantiate the target class with the default constructor or a parameterized constructor if a parameter mappings exist. If you want to override the default behavior of object factory, you can create your own. The object factory interface is very simple. It contains two create methods, one to deal with the default constructor and the other to deal with the parameterized constructors. Finally, set properties method can be used to configure the object factory. Properties defined within your body of the object factory element will be passed to the set properties method. After initialization of your object factory instance. MyBatis-config.xml. Now we are considering plugins. Simply implement the intercept interface, being sure to specify the signatures you want to intercept. The class, the interface intercept, which is in org.apache.ibatis.plugin. MyBatis allows you to intercept calls to a certain points within execution of a mapped statement. By default, MyBatis allows plugins to intercept method calls of executor, update query, flash statement, commit, rollback, get transaction close is closed, parameter handler, get parameter object, set parameters, result set handler, handle result set, handle output parameter, statement handler, prepare parameterized batch update query. The details of these class methods can be discovered by looking at the full method signature of each. The source code, which is available with MyBatis, each MyBatis release, you should understand the behavior of method you are overriding. Assuming you are doing something more than just monitoring calls, if you attempt to modify or override the behavior of a given method, you are likely to break the core of MyBatis. These are low-level classes and methods, so use plugins with caution. Using plugins is pretty simple. Given the power they provide, simply implement the interceptor interface, being sure to specify signatures you want to intercept. The plugin above calls the update method on the executor instance, which is an internal object responsible for low-level execution of mapped statement, not overriding configuration class. In addition to modify the core MyBatis behavior with plugins, you can also override the configuration class entirely. Simply extend it and override any method inside the inside and pass it to the core. Pass into the call to SQL session factory builder.build myconfig method. Again, though, this could have a severe impact on behavior of MyBatis, so use caution. mybatis-config.xml. Implement pre-processing if needed. Implement post-processing if needed. Now we are considering environments. The environments element define how the environment is configured. MyBatis can be configured with multiple environments. This helps you to apply your SQL maps to multiple databases for any number of reasons. For example, you might have a different configuration for your development, test and production environment, or you may have multiple production databases that share the same schema and you would like to use the same SQL maps for both. There are many use cases. One important thing to remember though, while you can configure multiple environments, you can only use one SQL Session Factory instance. If you want to connect to two databases, you need to create two instances of SQL Session Factory, one for each, and for three databases you need three instances, and so on. It's really easy to remember. One SQL Session Factory instance per database. To specify which environment to build, you simply pass it to the SQL Session Factory builder as an optional parameter. These two signatures that accepts the environments are here. If the environment is omitted, then the default environment is loaded as follows. The environment element defines how the environment is configured. Notice the key sections here. The default environment ID, for example, default equal development. The environment ID for each environment defined, ID, for example, ID equal development. The transaction manager configuration, for example, type equal JDBC. The data source configuration, for example, type equal pooled. The default environment and the environment IDs are self-explanatory. Name them whatever you like. Just make sure the default matches one of them. With transaction manager, there are two transaction manager types, that is type JDBC and managed, that are included with MyBatis. JDBC, this configuration simply makes use of the JDBC commit and rollback facilities directly. It relies on the connection retrieved from the data source to manage the scope of the transaction. By default, it enables auto commit when choosing the connection for a compatibility with some drivers. However, for some drivers, enabling auto commit is not only unnecessary but also an expensive operation. So since version 3.5.10, you can skip this step by setting skip set auto commit on clause properties to true. Other type is managed. This configuration simply does almost nothing. It never commit or roll back the connection. Instead, it lets the container manage the full life cycle of the transaction. That is, for example, JEE application server context. By default, it does not close the connection. However, some containers don't expect this, and thus if you need to stop it from closing the connection, set close connection property to false. If you are planning to use MyBatis with Spring, there is no need to configure any transaction manager, because the Spring module will set its own overriding any previous set configuration. Data source, the data source element configures the data source of a JDBC connection objects using standard JDBC data source interface. Most MyBatis applications will configure the data source as in the example. However, it's not required. Realize though that's to facilitate lazy loading, and this data source is required. There are three built-in data source types: unpooled, pooled, and JNDI. Unpooled, this implementation of a database simply open and closes connection each time it is requested. While it's a bit slower, that is a good choice for simple applications that do not require the performance of immediately available connection. Different databases are also different in this performance area. So for some, it may less important to pool. This configuration be ideal. pooled this implementation of data source pools the DBC connection objects to avoid the initial connection and authentication time required to create new connection instance. This is a popular approach for concurrent web application to achieve the fast response. JNDI option is this implementation of data source is intended to use for the containers such as EGP or application server that may configure the data source centrally or externally and place the reference to it in JNDI context. Now we are considering database ID provider. Given that usually that string is too long and that different versions of the same product may return different values, you may want to convert this to a shorter one by adding properties like here follows. The database ID provide the interface database ID provider, which is in the package org.apache.ibatis.mapping, should return an old ID to identify the type of this database. That ID can be used later on to build different queries for each database type. This mechanism enables supporting multiple vendors and versions. MyBatis is able to execute different statements depending on your database vendor. The multi-DB vendor support is based on the mapped statement database ID attribute. MyBatis will load statements with no database ID attribute or with database ID that matches the current one. In case some statement is found with or without the database ID, the latter will be discarded. To enable the multi-vendor support at the database ID provider, to MyBatis config.xml file as follows here. DB vendor implementation, DB_vendor implementation database provider sets the database ID string returned by database meta data hash get database product name method. Given that usually that string is too long and thus different versions of the same product may return the different values, you may want to convert it to a shorter one by adding properties like as follows. When properties are provided, the DB_vendor database provider will search the property value corresponding to the first key found in the return database product name or null if there is no matching property. In this case, get database product name method returns Oracle data direct. The database ID will set to Oracle. You can build your own database ID provider by implementing the interface org.apache.ibatis.mapping.database ID provider and registering in it it in the mybatis-config.xml. Since the 3.5.2 changed to default method and nop, now we are considering mappers. For example, here now that the behavior of MyBatis is configured with the previous configuration element, we are ready to define our mapped SQL statements. But first we need to tell MyBatis where to find them. Java doesn't really provide any good means to auto discovery of this regard. So the best way to do is to simply tell MyBatis where to find the mapping files. You can use class path relative resource references, fully qualified URL references, including file colon / URL, class names or package names, for example. Here using class path relative resources, you can use using URL fully qualified path, URL mapper interface classes, register all interfaces in a package as mappers. These statements simply tell MyBatis where to go where to go from here. The rest of the details are in each of the SQL mapping files, and that's exactly what the SQL mapping files. Using class path relative resources. Now we are considering SQL session builder in SQL sessions in Java API. Here is an example of building SQL session factory from an mybatis-config.xml file. The SQL session factory builder builds SQL session instances. Is in the package org.apache.mybatis.session. The SQL session factory builder has 5 build methods, each which allow you to build a SQL session factory from different sources. The first 4 methods are the most common, and as they take input stream instance that refers to an XML document, or more specifically the mybatis-config.xml file discussed here. The optional parameters are environment properties for the other build methods. Environments and properties. Environment determines which environment to load, including the data source and transaction manager. For example, if we put environment here, we can consider this one, or if we take the default one, the first 4, if you call the build method that takes the environment parameter, then the MyBatis will use the configuration for that environment. Of course, if you specify invalid environment, you could receive an error. If you call one of the build method that does not take the environment parameter, then the default environment is used, which is specified as the default equal development in the example here. If you call here if you called a method that takes a properties instance, then the MyBatis will load those properties and make them available to your configuration. Those properties can be used in the place of most values in the configuration using syntax $, open curly brace, prop name, close curly brace. Recall that properties can also be difference from the MyBatis -config .xml file or specified directly within it. Therefore, it is important to understand the priority. We mentioned it before also, but here we are telling it again. If the property exists in more than one of these spaces, MyBatis load them in the following order. Properties specified in the body of the properties element are read first. Properties loaded from the class path, resource, or UR attributes of the properties elements are read second, and override then duplicate properties already specified. Properties passed as a method parameter are read first, read last, and the override any duplicate properties that may have been loaded from the properties body and the resource URL attributes. Thus, the highest priority properties are those passed in as a method parameter, followed by resource or URL attributes, and finally the properties specified in the body of the properties element. To summarize, the first four methods are largely the same. Here build method, but with the override they allow you to optionally specify the environment or properties in build methods. Here is an example of building SQL session factory from an MyBatis -config.xml. Notice that we are making use of the resources utility class, which lives in the org.apache.ibatis.io package. The resources class, as its name implies, helps you load resources from the class path, file system, or even a web URL. A quick look at the class source code and inspection through your IDE will reveal its fairly obvious set of useful methods. Here's a quick list. The final build method takes an instance of the configuration. The configuration class contains everything you could possibly need to know about SQL Session Factory. The Session Factory instance. The configuration class is useful for introspecting on the configuration, including finding and manipulating SQL maps. Not recommended once an application is accepting requests. The configuration class has every configuration switch that you have learned about already and only exposed as a Java API. Here's a simple example of how to manually a configuration instance and pass it to a build method to create a SQL session factory. Now you have SQL session factory that can be used to create SQL session instances. Now we are considering SQL Session Factory. SQL Session Factory has 6 methods that are used to create SQL Session instances. In general, the decision you will be making when selecting one of these methods are transaction. Do you want to use transaction scope for the session, or use auto commit? Usually means no transaction with most databases and no JDBC drivers. Connection, do you want MyBatis to acquire a connection from the configured data source for you, or do you want to provide your own? Execution, do you want MyBatis to reuse prepared statement and or batch updates including inserts and deletes? The set of ordered open session method signatures allow you to choose any combination of these options that make sense. The default session method or default open session method that makes no parameters will create a SQL session with the following characteristics. Transaction scope will stand, that is not auto commit. Connection object will be acquired from the data source instance configured by the active environment. The transaction isolation level will be the default used by the driver or data source. No prepared statement will be reused or no updates will be patched. Most of the methods are pretty self-explanatory. To enable auto commit, pass a value value of true to the optional auto commit parameter to provide your own connection. Pass an instance of connection on the connection parameter. Note that there is no override to set both the connection and auto commit. Because MyBatis will use whatever settings that provided connection object is currently using. MyBatis uses a Java enumeration wrapper for transaction isolation levels called transaction isolation level, but otherwise they worked as expected and have the 5 level supported by JDBC. None, real, uncommitted, real, committed, repeatable, read, serializable. The one parameter that might be new to you is executor type. This enumeration defines 3 values. Executor type dot simple. This type of executor does nothing special. It creates a new prepared statement for each execution of a statement. Executor type reuse. This type of executor will reuse prepared statement. Executor type batch. This executor will batch all update statement and demarcate the necessary if selects are executed between them to ensure an easy to understand behavior. There's one more method on SQL Session Factory that we didn't mention, and that is get configuration method. This method will return an instance of configuration that you can use to introspect upon the MyBatis configuration at runtime. Note, if you have used a previous version of MyBatis, you will recall the session that session's transaction and batches all nothing separate. This is no longer the case. There are 3 neatly contained within a scope of a session. You need to deal with transaction or batches separated to get full benefit of them. This interface SQL Session Factory creates an SQL session out of connection or data source. This is in the package octo.apache.ibatis.session. Now we are considering ensuring that SQL session is SQL session is closed in SQL session. The best way to ensure this is to use the following unit of work pattern. SQL session, interface SQL session. This is in the package org.apache.ibatis.session, the primary Java interface for working with MyBatis. Through this interface, you can execute command, get mappers, and manage transactions. Void close method. The most important thing you need to ensure is the close. To close any session that you open, the best way to ensure this is to use the following unit of work pattern here. Just like SQL session factory, you can get the instance of configuration that the SQL session is used by calling get configuration method. Configuration, get configuration. Here the following 3 lines are pseudocode for doing some work. Here the as an exception example, we can consider invalid configuration exception. This is in the package org.mybatis.generator.exception. As an exception example 2, we can consider SQL session exception. This can occur in settings auto mapping unknown column behavior. If there's a fail mapping, it can throw SQL session exception. Now this is the end of my presentation. Thank you very much for watching it.